All right, so in this last video, we're going to take a look at zeros, which we've seen before. So this, again, is on your vocab sheet, so you can pull that up and follow along. Zero is another word for x-intercept. So when we're looking at the definition right here, it says a real number is a zero if and only if. What that means is that it works both ways. If f of a equals 0. So the value that you substitute into the function has to make the function equal to 0. And that'll give you an x-intercept. When we look at this box, there's 4 different statements. What these are saying is that they're the same thing, they're just a different way of saying it. So what we looked at already, number 1, a is a 0 of f. Number 2, a is a solution of the equation f of x equals 0, so that's what we were talking about up here. Substituting it in makes the function equal to 0. Number 3 is another way of saying it, that x minus a is a factor of the polynomial. So if you know that this a value, let's say 2, is a 0 of the function, you could factor out x minus 2 from the polynomial. And then finally, that it's an x-intercept. So 0 and x-intercept are interchangeable terms. Last piece down here is a turning point of the function. The turning point is where the graph changes from increasing to decreasing or vice versa. And the polynomial, so for example, this last piece is talking about how many potential turning points a function could have. So it says a polynomial function of degree n. So let's assume our polynomial has degree 3. Oops. So we have 3 is our degree, meaning that's the highest power of the polynomial. So it would be, for example, a cubic function, and we might have some other terms along with it. Then it would have at most n minus 1 turning points. So if we take this degree of 3 and subtract 1, it would have at most 2 turning points. Now it might not have 2 turning points, but it will have at most. It cannot have more than 2 turning points. Thinking about the same function, the other piece that it's talking about is how many zeros it could potentially have. And at most, n zeros. So the same function, x cubed, could have at most 3 zeros. So whatever the degree is, that's how many potential zeros it could have. And the last piece, we're going to take a look at just a reminder of factoring. So I've got one quick example for determining the zeros. So the first thing we're going to do is start by replacing f of x with 0 and solving for x. So when you see a quadnomial, a polynomial with 4 terms, your first thought should be to factor by grouping. So remember, when we're factoring by grouping, we factor out the GCF from the first 2 terms, in this case x squared, leaving us with x plus 5, and then factoring out the GCF from the last 2 terms, in this case negative 9, leaving us with x plus 5. So our goal is always to get these binomials here to match. Once they match, that becomes our GCF. We're going to factor out our x plus 5. And what's left from the first term when we cancel out this x plus 5 is x squared. Canceling out the x plus 5 that's from the second term, we have a minus 9. Now in this case, we can continue factoring because this x squared minus 9 is a difference of squares, and that we're going to factor into conjugates. So we looked at factoring review in the appendix chapter, unit A. If you need some additional help remembering all of the different types of factoring, please come in and see me sometime. All right, so to determine the zeros, remember all of this is equal to 0. So now that we have it in factored form, we use our zero product property and we set each term equal to 0 to solve. So we've got x plus 5 equals 0, x plus 3 equals 0, and x minus 3 equals 0. Finish my equation there. And then solving each of these, we're going to subtract 5 from both sides on the first one, subtract 3, and add 3. All right, so that's the zeros. The next part is another review of identifying end behavior. So our degree for this one is 3, so that's going to look like a snake. The leading coefficient is 1, which is positive. So for end behavior, we're going to have a quick sketch of the graph. It'll look something like this. And as x approaches negative infinity, so that's off to the left, our graph is decreasing. So the function f of x will approach negative infinity as well. And then as x approaches positive infinity off to the right, our graph is increasing. So f of x, the y values of the function, are approaching positive infinity as well. And here's your U-Try question.